Today we are in the second part with the confined space safety training. When we are talking about the confined space training, in this training we will discuss what are the confined spaces and what are the PTW requirement there and what we have to rescue the confined from the confined space. So four parts of this training, particularly confined space safety training. This is about me. Now is coming here. This for the uh, delegates. This training is for the delegates uh, who are working as a supervisor, confined space attendant, and particularly the attendant and someone who is working there. Objective of the training to provide awareness about the confined space safety to the delegates to prevent injury, illness, and disease to person who might be exposed to risk arising from those activities. Now, introduction. Now, over here we have the introduction uh, of, to the confined space. Definition of a confined space, legal and practical. Examples like tank, silos, vessels, manholes, pits, pumps, boilers, sewers, tunnels. Why confined space are dangerous? Means what's the reason that confined space are so dangerous? Accident statistic in real life case examples, employer and worker responsibilities. Now we will discuss these points one by one. So now we are coming to the definition of a confined space and legal and practical. What's the legal requirement and the practical? Confined space means a space that is large enough and so configured that an employee can boldly enter and perform assigned work and has limited or restricted means for entry or exit. For example, tanks, vessels, silos, storage bins, hoppers, wallets, and pits are spaces that may have limited means of entries and is not designed for continuous employee occupancy. occupancy. It's not designed for the routine works. Sometimes we need to go there and conduct our particular task there and then came back. So it means that confined space is not designed for uh, routine works. Now, uh, ADOSH, reference ADOSH COP number 27, confined spaces, version 4, and uh, 15 July 2024, confined spaces. Now see this guy is going in a like because in the center it's like open, but in the both sides it's not open. So how he will go there? Now, what are the confined space like tanks, manholes, boilers, furnaces, sewer, then silos, hoppers, excavation truck? These are confined space. Tanks, wellets, pipes, tunnel, ducts, bins, pits, hopper, excavation trench. Now, one by one we will discuss. These are confined spaces. Double hole, enclosed water tanks, pits, hoppers. These are the types. Chemical storage, silos. Why confined space are dangerous? Why dangerous? Because there is limited supply of oxygen. Confined space are dangerous because they combine restricted access, poor ventilation, and hazardous condition, which can quickly lead to serious injury or death. Here are the main reasons. oxygen deficiency. Oxygen level falls below safe limit, like normal 25.9, can be caused by uh, rusting, oxidation, biological decomposition, gas displacement, nitrogen, CO2, etc. Apex, dizziness, unconsciousness, brain damage, death within minutes. Now, toxic atmospheres. Hazardous gases, vapors, or fumes may be present. Hydrogen sulfide H2S, then carbon monoxide CO, and methane CH4, solvent vapor effect, poisoning, then respiratory failure, sudden collapse. Many toxic gases are colorless and odorless. Flammable, explosive atmosphere, accumulation of flammable gases or vapors. One spark can cause explosion, fire, water burn, common in 10 severe silos, fuel storage areas. Now, uh, engulfment risk. Worker can be buried or trapped by grain because sometimes we have to, this is also a confined space. So grain is there, sand, slug, liquid can cause suffocation, crushing injuries. Now restricted entry and exit, limited openings, difficult rescue operations, emergency evacuation is slow and complex. Many confined space fatalities occur during rescue attempts. Poor ventilation, hazardous gases accumulate, heat stress may develop, oxygen and oxygen cannot replenish naturally. Physical and mechanical hazards, moving machinery inside tanks, electrical hazards, slips and falls, poor lighting, extreme temperatures. Now, psychological effects, uh, claustrophobia, panic, stress, reduced decision making ability. Like psychological effects means claustrophobia, then panic, stress, reduce decision making ability because sometimes there is too much hot, too much cold, or sometimes light, not too much light. So, reduce decision making ability. So, stress. Why confined space are high risk? Because why confined space are having high risk? Hazards are often invisible because we cannot see the hazards. Condition can change rapidly. Rescue is difficult because this is not designed for the routine work. So the rescue, how when we trap, how we will take it out. Rescue is difficult. Worker may underestimate the danger. Confined space accident statistics and real life case examples. Confined space remain one of the most fatal workplace environment worldwide, mainly due to atmospheric hazard and failed rescue attempts, like accident statistics, global overview, then fatality pattern. Around 60% of confined space fatalities are would be rescuers. 60%, and 40% die. Most incident involves oxygen deficiency. Then toxic gases like H2S and CO, engulfment grains and slugs. Now, common location of incidents: storage tanks, severe and manholes, silos and grain bins, chemical vessel, ship cargo holds. Many deaths occur within minutes of entry. Because if there is oxygen deficiency, that only 2-3 minutes, halas. Main, but if it's uh, we have the oxygen concentration like 16, 18, then it's take like time. Will be there. How much oxygen, when will it be near? We will have this later. Main cause identified. No gas testing before entry. Why? Why? Main cause is identified. Now, no gas testing before entry. No permit to work system. No standby attendant. Inadequate rescue plan. Poor training. Failure to isolate energy sources. Real life case example. Now, case number one, severe cleaning fatality hydrogen sulfide incident. Two workers entered a severe without gas testing. H2S concentration was high. So, what happened? First worker collapsed immediately. Second worker entered to rescue him and also collapsed. Both died from toxic exposure. Root causes no atmospheric testing, no ventilation. Now, no rescue equipment. They don't have rescue equipment. No trained standby person. Lesson learned, never enter without gate testing and a rescue plan. Rescue plan, then training, everything, testing. After this, we have to enter. Otherwise, khalas, we will not enter. Then, case number two, grain silos engulfment incident. Worker entered a grain silo to clear blockage while there is some leakage in the grain silos while grain was flowing. What happened? Grain collapsed like quicksand. Worker was engulfed within seconds. Rescue unsuccessful. So, root causes failure to isolate moving grains, no lockout tagout, no harness lifeline, no permit. Lesson learned, always isolate mechanical movement and use for protection. Now, case study number three, tank cleaning explosion. There was tank cleaning activity going on and explosion happened and worker was suffocated. Now, worker cleaning a fuel tank using non-intrinsically cynically safe lighting. What happened? Flammable vapors present. Spark triggered explosion. Multiple serious burn injury. Root causes. No gas monitoring. No explosion. No explosion proof equipment. Poor risk assessment. Lesson learned. Test for flammable gases and use certified. Now, rescue fatality. Now, sometimes the rescue they enter to the workplace and they are become victim. Rescue fatality. Most common scenarios: incident. Worker collapse in confined space. Supervisor rush in without PPE. Now he was rescued. He become the victim. Multiple fatalities. Statistics show that over half of confined space, these are rescuers acting emotionally without proper equipment. Now, atmospheric hazard are the leading cause of death. Most incidents are preventable. Rescue attempts without equipment increase. Rescue attempts without equipment increasing fatalities. Now, permit to work and gas monitoring are critical. Training in emergency planning save lives. Now here, employer's responsibility. As per the ADOSH COP number 27, section 3.1.1, this course we design basically are on the ADOSH COP number 27. General requirement. Employer shall comply with the ADOSH element number first, rule, responsibility, and self-regulation. Identification. Identify and record all activities requiring confined space entry. Clearly mark confined space with confined space permit. Required do not enter. Without permit, do not enter. First of all, we have to identify. Sign must be in Arabic, signage must be in Arabic and English, and other relevant language. Like, see, the people, they are working in confined space, particularly the majority, the Indian and Pakistani people are there in Bangladesh. So, it's better also to have signage in their languages and also training in their languages. because this confined space and this labor work are done by our Indian and Pakistani people and Bangladesh. So, and also Nepal people, they are working. So they are exposed to this. So if we conduct for them training, will be in their language. Avoid entry where possible. If possible, do not enter. Entry shall only be allowed when it is not reasonably practicable to achieve the work without entering the confined space, if possible. Competency. Ensure all persons entering are competent, properly trained, fully aware of emergency procedures. Training must comply with ADOSH, like element number 5, training and management consultancy. In mechanism, like someone who is providing the training will have practitioner registration. Like myself, also registered with the ADPC. Permit require confined space, PRCSP. Employer must develop a PRC, permit required confined space program include list of all permit required confined spaces program. Second, list of competent entrant. Who will go in? Entrant. Entrant means who go in the confined space. List of competent rescue personnel. Who will participate in rescue? Their list. Equipment list means including calibration records. Like what type of equipment the gas detector should be calibrated. Entry records, risk assessment, safe working procedures. The employer have to provide all these requirements. Risk assessment, section 3.6. This is the as per the ADOSH-CoP number 27 requirements. For each entry, conduct activity specific risk assessment, consider atmospheric hazards, previous contents, residues, emergency scenarios, risk to other outside the space. Follow ADOSH element number 2, risk management. So, if we have the confined space, we have to conduct the risk management or risk assessment for this. Safe working procedure, COP number 3.7, must include supervision, safety watch, standby man, communication system, rescue plan, gas testing and monitoring, ventilation, isolation, mechanical isolation, electrical, liquid and gases. PPE. PPE means personal protective equipment. NRP, respiratory protective equipment. RPE means respiratory protective equipment. Fire prevention, oxygen egress, limiting exposure duration. Emergency arrangement 3.8. No entry without a specific rescue plan. A rescue arrangement must reduce risk to rescuer, include resuscitation equipment where foreseeable emergency plan must be activity and date specific. Now communication 3.9 must ensure communication inside the space, communication between inside and outside, ability to summon help, intrinsically safe equipment, reliable and tested system. Confined space entry permit 3.10. Now, confined space permit must be completed. Oxygen level must be 19.5 to 23.5. Please be with me. When we are talking about the oxygen level, as per the international standard, 19.5 to 23.5. But as per the ADOSH, as per the EDNOC and Aramco, the 19.5 will be 20 because this is less as per them. S will be 20. And the 23.5 will be 23, not 23.5, 23. So over here plus 5 and over there also minus 5. Flammable gases must be less than 5%. Alien lower explosive limit. Standby person required. Permit must be signed up after completion. Now, implies responsibility. As per ADOSH COP number 27.3.152. General duties. Employer must comply with the element number first. Authorization never enter unless authorized. Entry enter only after control measures are implemented. Complies follow safe working procedure, use equipment and PPE properly, comply with permit condition. Now, hazard reporting. If we see the hazard, immediately report hazards, unsafe conditions, equipment defects, then change in atmosphere. Now, key ADOSH principles. ADOSH emphasize identification. Identify all let's see ADOSH key principles for this COP number 27 for the confined space. Identify the confined space. Where is the confined space? We have to identify. Risk assessment. Conduct the risk assessment for the confined space. Because see, the risk assessment for all the confined spaces will not be the same. Identify and if some are same, make this combine. Some are different for this separate confined space risk assessment. Clear? Not the general, specific one, please. The risk assessment that we are conducting for a confined space not will be a general statement. It should be confined space specific risk assessment, not the general one. Confined space specific risk assessment. Now see, some people say that from the confined space, the severity is catastrophic. But it depends. It depends. The severity or the probability of risk for a confined space, it depends on the confined space. Like we have some confined space. This is quite wide and it's not too much shallow. So easily we can rescue. So over there, the severity even you can consider it's like major, not catastrophic. In some of the confined space, too much risk is there. So we cannot take this light. So permit control competency of the someone who is working in the confined space, supervision, level of supervision of the confined space, emergency preparedness, documentation, to the confined space team, supervisor responsibility to ensure that all hazards associated with the confined space have been identified and addressed. To ensure adequate protection is provided to the entrant who goes in the confined space to work there. Verified adequate logout, tagout where required. To support the entry attendant, authority is controlling access to a confined space. The attendant means the someone who allow the entrant to work and will be there up to that time when work is not finished. To assist that all persons involved are aware of the hazard associated with the space. To assure that rescue system services are available prior to entry. To verify that all persons have exited prior to close the space. Now see, entry supervisor inspecting a worker before entry. Now this is the entrant. This is supervisor or attendant. Entrant response. Now entrant who go in, what will be his responsibility? To ensure that the space has been adequately ventilated, isolated, impeded, or otherwise made safe for entry. To immediately exit a space without question upon word of the attendant, no matter what the reason. To follow all safety rules and procedures that apply to the job, to be familiar with the work to be performed and the procedure that apply to do the job, to use the appropriate PP awareness whenever necessary. Now, attendant. This was the entrant attendant. The entry attendant is trained on specific duties such as to monitor and communicate with the entrant during the job and during entry and exit to help ensure their safety. The attendant may not not leave his post for any reason while personnel are in space unless relieved by another qualified attendant. To control access to confined space and maintaining logs. To summon emergency assistance as needed. To assist agent in and around the space and take action on the same. To keep records of confined space work, such as ear test, result, personal entry, exit, etc. Now, confined space hazards. This is the second part. Now we came to the second part. Oxygen deficiency and enrichment. Sometimes low oxygen, sometimes high oxygen. Toxic gases and vapors. H2S, CO, ammonia, and solvent. So we will discuss this now one by one. Flammable explosive atmosphere. Engulfment liquid grain powders. Mechanical and electrical hazards. Heat stress and restricted movement. Poor visibility and noise. Now, oxygen deficiency. See, oxygen deficiency. Oxygen is consumed in combustion of material. A number of processes consuming ore, such as welding, cutting, brazing, bacterial action, fermentation process, chemical reaction, formation of rust. Number of people working in confined space. Now more people there and no fresh air supply is there, so the oxygen will be no more. Amount will be down. Now, amount of physical activity can be reduced as the result of oxygen displacement by other gases. Now, see, oxygen and carbon dioxide go out. If the 19.5 is the minimum acceptable oxygen level, 15 to 19, decreased ability to work, strenuously impaired coordination, early symptoms. Now 12 to 14, respiration increase, poor judgment. 10 to 12, respiration increase, lips blue. Now see here, comma and 40-second, did see, comma, if we have this. Over here we see nitrogen 78.9 nitrogen, this atmosphere, oxygen this is the argon, carbon dioxide, this is the molecular mass of dry air, 28.97. And for the oxygen, 32. Because oxygen is not in the O2, it is in the not in O2 in a molecular form. So O2 32. So oxygen is heavier than air. Huh? We have the air. The air we have 21% or 22.8%, 22.9% oxygen. But the air also we have other gases. Now we are discussing other gases like H2, H2S, CO, ammonia, solvent. So now come. These gases we will have to check or monitor in ppm, parts per million. Parts per million for H2S. When discussing concentration, we must first consider that concentration is relative to the sample size. Now see. Uh, Actually, why H2S is so dangerous? Because it directly attack on our CNS, central nervous system. It directly attack on our central nervous system. Like see, 0 to 10% rotten eggs smell. Then 20 to 10% ppm, we have sweet metallic odor. Above 100, no smell, because central nervous system is no more. it will be not effective. Now, sense of smell should never be relied on. The people they enter to the place, they say no, 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 no. It's not like it is because 10 little bit coming. Once they go ahead, the direct rate increase from 100 ppm, so they cannot smell. Because see, like testing, then even talking, then hearing, and then smelling. We are watching. We are doing this everything due to the brain. So this everything is covered by the brain. So now, is destroy our central nervous system means our brain. So when we breathe in more than 100 ppm, directly our central nervous system lose work. So what happens? What will the consequences? We cannot smell. So we cannot run away from the place and we directly unconscious. The sense of smell should never be relied on to detect it because after 100 we cannot detect. Receptors are there. Olfactory bulb receptors. These are the smeller. Now see, if we have 1 ppm, obvious and unpleasant odor can be detected. 10% unpleasant odors, possible eye irritation, respiratory, protection necessary when it becomes dangerous. 15 then again 20 burning sensation in eyes and irritation of the respiratory tract after 1 hour or more. Like see, once we come here, unconscious at once, permanent brain damage and death will like see 100. Loss of sense of smell after 3, 4, 5, 15 minutes. See, the people come and they say we don't have this. After 3 to 15 minutes, what happened? Smell is not working. Altered respirator pain in eyes. Drowsiness after 15 to 20 minutes, followed by throat irritation. So IDLHR, intensive death is coming later on. See now, toxic gases. What is this? Toxic gases. CO, oxygen, means carbon monoxide. It's odorless, colorless gas. Is combustion byproduct. Once we have full combustion, it will change to CO2. But incomplete combustion will change to CO. Now, 50% of this, 8 hours permissible. Here, slight headache discomfort. 600, 1 hour. What's the molecular weight of CO2? This 44. So like 32 and then CO. 16, see, 16 and then 16 and 12. 16, 16 and 12, see. This also like the year, huh? So it's going with the year. So also 28 molecular weight. Now here, ammonia. Ammonia we also have from the Lexi is a colorless gas with strong pungent smell. It's widely used in industry, refrigeration system, fertilizer, and cleaning chemicals. So health hazards, irritation eyes, nose and throat, cause coughing and breathing difficulty, can cause chemical burns to skin and eyes. Now, toxic gas in vapors, ammonia, high concentration can cause lungs damage, pulmonary edema, fertility in confined space, fire explosion hazard, flammable between 15 to 28 percent concentration in air, can explode in confined area. Now, environmental hazards, toxic to aquatic life, then can contaminate the soil and water ammonia. Now, flammable explosive limit. The range of concentration between which If a gas is present, then it can ignite, causing a fire explosion and called as flammable explosive range. Now see here, flammable explosive atmosphere, common types, explosive that burns, methane, steam gas. The methane gas is the gas that we are using for LLPG, means for burning. Vapor of fuel, solvent fan, coal or grain dust, measurable by LEL. Lower exposure level, more than 10 is a serious hazard. Now see here. Okay, LEL, rain, then too rich, then direct fire. Engulfment. Now this guy, trap here, flooding our confined space, clotting members. See, engulfment. Okay, mechanical and electrical hazards. Mechanical hazards. Mixer, agitator, conveyor, then augers, then rotating shafts or blades, crushing or entanglement risk. Risk amputation. Amputation means cutting, crushing, entrapment, fatality, injury, fatal injuries. Stored mechanical energy, stored. This was about the moving machinery. Now, stored mechanical energy. Pressurized system, compressed springs, elevated loads, residual pressure pipelines, then sudden release causing impact injuries. Now, mechanical and electrical hazard, engulfment, falling objects, unexpected equipment startup, remote control activation, automatic system restart, failure to isolate power, then risk, fatal, intra payment. Now, electrical hazard in confined space. Electrical hazards are particularly dangerous because confined space often are damp or wet, have metal walls, conductive, restrict escape. Now, electric shock, faulty wiring. Now here, damage extension cable, contact with energized parts, then cardiac arrest, burn fatal injuries. Now, arc, this is from the mechanical scene. Arc flash, arc blast, switch panel, inside tanks, faulty connection. This is the arc blast, severe blast, burn, explosion. Static electricity also we have flammable, atmosphere. Now, poor bonding and grounding explosion. Now, heat stress. Why it happened? Poor ventilation, high ambient temperature, hard process welding steam lines, PP increasing body heat, high humidity. Now risk, dehydration, heat exhaustion, heat stroke, dizziness. Now restricted movement, heat stress. Why it happens? Small entry exit openings, narrow or awkward space, obstacle inside, bulky PPE or breathing apparatus. Now risk, difficult escape in emergency, musculoskeletal injury, increased fatigue, delayed rescues. Poor visibility and noise, like poor visibility, inadequate lighting, dust, fumes, vapors, smoke from hard works, then shadow area inside the tank are fit. Now, poor visibility and noise like risk, slip, trip, fall, contact with moving machinery, incorrect connection, maintenance error, delayed emergency, evacuation, control, adequate temporary lighting, intersectionally safe flame, if flammable atmosphere risk, good ventilation, free entry inspection, housekeeping. Now here, risk assessment for confined space. How we will conduct the risk assessment for a confined space. So now we're discussing the confined space risk assessment. Confined space hazard identification. What are the hazard and what are the control? Task-based risk assessment. Identifying vulnerable workers. Select suitable control measure. Hierarchy of control applied to confined space when entry must be avoided. Like if we can do this from outside, no need. Confined space hazard identification. Identify all potential hazard before entry, oxygen deficiency or enrichment, toxic or flammable gases, mechanical electrical energy, engulfment liquids, sludge in grave, heat stress, poor visibility and noise, restricted entry exit, use gas testing inspection review of SDS procedure information. Now, task-based risk assessment. Assess risk based on the specific job, but just the space consider. Nature of the task, welding, cleaning, maintenance, duration of the work, tools, equipment use, number of workers, emergency arrangements, identify hazard, evaluate risk, implement control record and permits. Now identify vulnerable workers. Some workers may be at high risk. New or inexperienced workers, young or older workers, worker with medical condition, pregnant workers, contractor unfamiliar with the site. Ensure medical fitness, then supervision and proper training. Now hierarchy of control applied to confined spaces. Elimination. Avoid entry. Substitution, use safer chemical tools. Engineering control, ventilation, isolation, gas detection. Administrative control, permit system, training, supervision. PP, respirator, harness, protective clothing. Always try eliminate first. Now, when entry must be avoided, like avoid confined space entry when work can be done from outside. Atmosphere cannot be made safe. Rescue plan is not available. Proper isolation cannot be achieved. Then worker are not trained or competent. No rescue plan means not a no entry. Now, section number 4. In the 4 number section, we will now discuss permit to work. Permit to work, PTW. What is a PTW system and why it is required? What is a PTW system and why it is required? Types of permit, entry, hard work, isolation. PTW rules and responsibilities, permit issuer, permit receiver, authorized entrant, standby person, whole watch. PTW validity, endure, suspension, and close out. Now, common PTW failure and lesson learned. Now we will also discuss this. What is a PTW system and why it is required? PTW, permit to work, is a formal written system to control high risk work required because confined space, confirm hazards are identified, ensure control are in place, define responsibilities, prevent authorized, unauthorized entry, comply with legal requirement like ADOSH-SF, no valid permit, no work. Types of permit, confined space entry permit, hard work permit, isolation, lotto permit. PTW rules and responsibilities. What are the rules and responsibilities of PTW uh, permit issuer? Competent person verifies risk assessment. Confirm control are in place. Authorizes the permit. Permit receiver supervisor understand permit conditions. Brief the team. Ensures control are maintained. Now authorized entrant. Follow permit conditions. Use PPE correctly. Exit if unsafe condition occur. Standby person, hold watch, remains outside the space. Maintain communication. Monitor entrant. Initiates emergency response. Now, PTW validity, handover, suspension, and closure. Validity, limited time, shift based. Sometimes the companies they give the ship-wise PTW, but some works are continuous. Like we are doing some work in confined space, but it's continuous work daily, both sides. So in each ship, then the format will be validated, verify. Like what they did in the start, this will be every day. Handover, rebrief new team, a revalidate format also. Suspension, stop work if condition change. Closure, confirm work complete. Remove isolation, safety, cancel permit. Now, common PTW, failure and lesson learned. No gas testing, poor isolation load of failure. Incomplete hazard identification. No standby person. Permit not revalidated after break. Most confined space accident happen due to poor permit control and supervision. Now isolation and preparation for entry. Mechanical isolation, blanking, locking. Electrical isolation, lotto. Process isolation, fluid gases. Cleaning, purging and ventilation. Safe exits and egress. Barricade and signage. Now mechanical isolation, blanking, locking. Install spade blanks plates in pipelines. Disconnect and lock moving parts. Block or secure rotating equipment. Release stored pressure. Prevent unexpected movement or materials flow. Then electrical shutdown, isolation, lotto, switch off power source, apply lockout tag out lotto, test for zero energy. Lock means the potential energy. Lock control panel, prevent accident, start up or electrical shock. Now here, process isolation, fluid and gases. How we will uh, save ourselves from this. Close and lock wallows, double block and bleed, drain lines and tanks, depressurize system, stop hazardous liquids or gases entering the space, cleaning, purging and ventilation, remove residues and slugs, flush with water or inert gas, use enforced air ventilation, continuous gas monitoring, make atmosphere safe for entry. Now safe access and egress. Secure ladders or platform. Use tripod. Tripod will be there in lifeline vertical entry. Ensure clear entry exit. Provide adequate lighting. Quick evacuation is in emergency. Barricading and signaging. Install physical barrier. Warning signs. Sign confined space. Authorized entry only. Restrict unauthorized process. Mark exclusion zone, control access and prevent accident. Now, gas monitoring and atmospheric testing. Why gas testing is critical? Types of atmospheric hazards, oxygen, flammable gases, LEL, lower exposure limit, toxic gases, ppm, then gas detector types, portable multi-gas monitor, fixed detector. So, free entry testing requirements, continuous monitoring during entry, calibration, bumping testing, in maintenance, interpreting gas monitor alarm action if limits are exceeded. Now, why gas testing is critical? Why gas testing is critical? For the confined space, atmosphere cannot be seen or smelled safely. Most confined space deaths are atmospheric related. Identifies oxygen deficiency, toxic and flammable gases. Confirm space is safe before and during entry. Test before you enter. Types of atmospheric hazard like normal 20.9 to 19.5, oxygen like deficiency, asphyxiation risk. 23.5 high, no enrichment, so explosion. Now flammable gases, lower exposure limit is 10 or above, so it's unsafe. Toxic gases, like examples, ppm, CO, this, we will stop. Now, gas detector type. Sometime we have fixed, like these are the fixie, and there's a mobile. Multi gas detector, uh, carried by workers. They keep here, fixed detector installed permanently. Pre-entry test, pre-entry test requirement. Test from outside before entry. Test at top, middle, bottom. Calibrate detector. Record readings on permit. No safe reading, no entry. Continuous monitoring during entry. Keep detector inside space. Monitor throughout work. Retest if work conditions change. Required for hard work or high risk task. Now calibration, bumps testing and maintenance. Calibrate, adjust to the equipment like the gas, like see this we are using will be monitor, will be calibrated. Okay, quick test before use. Replace sensors and required. Maintain calibration records. Faulty detector, fast safety. Interpreting gas monitoring alarm. Lower alarm, like alarm. While high alarm, danger level. Follow manufacturer set points. Treat alarm as real unleash, proven otherwise. Action if limits are exceeded. Stop work immediately. Like we are measuring the CO or H2S too much. Like now heat come up. So now the concentration of H2S becomes more. So what we will do? Then evacuate space. Informal supervisors, inform supervisors stand by. Ventilate and retest. Do not re-enter until safe. Now, safe working practice in confined space. Entry and exit procedures, communication methods, use of ventilation equipment, lighting intersenically safe tools, PP and RP selection, work duration limits and fatigue control, contractor management and supervisor, then loan working. So we will take this one by one. Entry and exit procedure. Valid confined space permit approved, gas test completed and recorded, LOTO confirmed, then standby person in place, safe access, ladders tripod provided, exit immediately if unsafe condition occur. No permit, no work. Now, communication. The entrant and the attendant, there will be communication. Two ways radio instantly safe if required, like see, hand signals, lifeline signal, continuous contact with standby person, fast and emergency response, communication between the entry and the entrant and the entry attendant shall be established by means of radio or other means. Now, use of ventilation equipment. Force air ventilation before entry, continuous ventilation during work if required. Do not use oxygen for ventilation. Do not use oxygen for ventilation. Ensure air intake is from clean source. Lighting and intrinsically safe tools. Use low voltage or explosion proof lighting. Intrinsically safe tools and flammable atmospheres. Avoid spark producing equipment. Unleash hard work permit issues. PP and RP. PP means like uh, re- um, respirable protective equipment. Clear? Helmet with chain sharp. Then respiratory protective equipment. Gloves, coverall, safety boots. Now harness with lifeline, vertical entry, respiratory protective protection SCBA. Self-contained breathing apparatus or cartridge type such as risk, as per risk. PPE must match atmospheric risk. Now see, these are the PPEs. Now, work duration limits and fatigue control. Apply workplace cycles, monitor heat stress, limit time inside space, ensure hydration, rotate workers if required, contractor management and supervision, verify contractor competence, ensure confined space training, conduct toolbox tasks, monitor compliance with permit, clear supervision and accountability. Poor supervision measure excellent risk. Now here, lone working. Lone working may be prohibited. Worker should then work in a buddy system. If any one worker has to come down, he shall be accompanied by the other worker. Now, emergency arrangements and rescue planning. Why rescue without entry is critical. Confined space emergency scenarios, collapse, gas exposure, fire explosion, medical emergency, rescue plan, requirements, trained rescue team, rescue equipment, communication system, prohibited practices, unplanned entry rescues. Now, coordination with emergency services, medical checkup. So now we will take this one by one. Why rescue without entry is critical? Most confined space did occur during rescue attempt. Untrained rescuers become victim. Reduce exposure to atmospheric hazard. Faster and safer emergency response. First option, rescue from outside. Let's see, rescue from outside using tripod and winch. We will not enter directly, we will catch out. Huh? Now, there are three types of rescue. Self-rescue. This is when the entrant recognizes hazards before they overwhelm him and exit the confined space. No entry, non-entry rescue. Using the tripod stand, the entrant is pulled out by the attendant, safety watch, and others. Entry rescue performed by highly trained professional who enter the confined space and rescue the victim. Now, there will be ambulance. In higher risk confined space, a fully equipped ambulance shall be stationed at all times during the activity to deal with any medical emergencies and transport the ill or injured to hospital if required. Now there is one rescue video. We'll take this later. I will take this in later. 8.2 Confined space emergency scenario. Collapse engulfment. Worker trapped by material or structure. Gas exposure. Oxygen deficiency or toxic gas inhalation. Fire explosion. In ignition of flammable atmosphere. More oxygen. Medical emergency. Heat stroke, cardiac arrest or unconsciousness. Rescue plan requirement. Trained rescue team, not general workers. Trained rescue team, not the general worker, because they will become victim. Now, rescue equipment, tripod, winch, SCBA, stretcher. SCBA video, there we will play there after. Reliable communication system, first aid and emergency response procedure, Plant test through drill. No rescue plan, no entry. No rescue plan, no entry. First of all, we have to arrange all these. Prohibited practice, unplanned entry rescue, entering without SCBA, no permit or gas test, no standby person. Never rush in without protection. Coordination with emergency services. Inform local emergency services in advance. Provide site access details. Share confined space hazard. Clear emergency contact numbers displayed. Now see here. Medical checkup. Medical checkup for the rescue team and the attendant and the entrant. Medical checkup. This based on the company procedure. But if you want to go in more detail, this you can have this in ADOSH-SF CoP number 5, like first aid and medical screening. Confined space rescue equipment, tripod and winch, full body harness, then in lifeline, breathing apparatus, SCBA line, then stretchers and rescue kits, then gas detector during rescue, inspection and maintenance of rescue equipment. Now, tripod and winch, see here. Used for vertical confined space entry, allows rescue without entry, must be securely positioned, rated for required load capacity, enable safe lifting up unconscious worker, full body harness and lifelines, mandatory for vertical entry, lifeline attached to winch. Proper lifting requirement, inspect before each use, prevent fall and enables quick retrieval. Now over here, as we discussed this before in the confined space, in the working at HRC, breathing apparatus, SCBA align, self-contained ear cylinder, emergency use, ear line system, continuous supplier ear, used when atmosphere is used, required for rescue in toxic or oxygen deficiency space. Let's see, oxygen deficiency when for the rescue also and for the places where there is a deficiency of oxygen, we have to use self-contained breathing apparatus SCBA. Now respirator. A respirator is a device designed to protect the wearer from inhaling harmful dust, fumes, vapors, and or gases. Respirators come in a wide range of type and size, used by the military, private industry, and the public. Respirator range from cheap single-use disposable mask to reusable model with replaceable cartridge. There are two main types of respirator: ear purifying respirator, dust mask, and supplied ear respirator. It will supplied ear. So two purifier, ear purifying respirator and supplied ear respirator. Supplied ear respirator will have ear and the ear purifier will not have ear. See, these are the ear purifier respirator. This is the supplied ear. We have oxygen cylinder here, ear cylinder, escape unit. See this work line. See work line unit. See some places we have work line. Work line unit can be used to work for extended period from time in hazardous. Like see, we have a hazardous atmosphere, so we can use this also. We also have this like we attach this with a supply source. Continuous if we are working, we have to use this. Like sometime we are using in the blasting booth, also in the painting booth, spray painting. They can use this, no? Filter is there, filter. Huh? Here is coming from this, and this the NIOSH approved supply, NIOSH approved filter, this filter and this becoming Class D era. Class D era. Now, self-contained breathing apparatus. See, self-contained breathing apparatus is filled with filtered compressed air, the same air that we breathe. So this not only oxygen, the same breathing. So the common air containing how much oxygen? 21.95. So 21%. We will take this 2 also later, SCBA 1 and 2. This there. Now, stretcher and rescue kits. We will have stretcher and rescue kits. Confined space stretcher, flexible type, first aid kit, rescue ropes and pulleys, then spine board if needed, then design for narrow space evacuation. Now, gas detector during the rescue. We have to detect the gas during rescue. A rescuer must carry multi-gas monitor. Continuous monitoring required. Do not enter alarm activate. Protect rescue team from secondary exposure. Inspection and maintenance of rescue equipment. Free use inspection. Scheduled periodic inspection. This part the rescue equipment. Maintain inspection record. Remove damaged equipment immediately. Poor maintenance rescue failure. Rules and responsibilities of the competent person. Authorize and trained. Then standby person, top management, supervisors, permit issuers, rescuer team members, training, certification, and repression training. Now see, now we are taking this one by one. Authorize and trained. What's his duty? Uh, Enters confined space, follow permit and safety procedure. Confined space entry, training PTW, awareness suppression every 1 to 2 years. Standby person, top management, or monitor, top man. Monitor, entrant, communicate with supervisor, initiate rescue if needed. Confined space awareness plus rescue procedure, repression annually. Supervisors, ensures safe entry, approves procedure, oversees operation, confined space supervisor, training, PTW management, repression every 1 2 years. Now permit sure, review and issues the confined space entry permit, PTW training, confined space risk, awareness, refresher annually. Rescue team members, perform emergency rescue, user rescue, uses the rescue equipment, confined space rescue training plus first aid, CPR repression at least annually. Now, authorize entrant, stand by, entry supervisor, safe permit issuer, then rescue team. Legal requirement standards, confined space regulation, OSHA, HCILO guidelines, employer duties, worker rights and responsibilities, penalties for non-compliance like ADOSH-SF CoP number, confined space, permit to work, logout and tagout. Okay, now, legal requirement and standards. Confined space regulation. Define confined space, require risk assessment, farmer monitoring, emergency planning. OSHA HC ILO guideline. Like these are the OSHA 29 CFFR 1910 146 HC confined space regulations, ILO guidance, risk-based entry, training, emergency readiness. Employer duties provide safe system of work, training, equipment, rescue plan, supervision. Now, worker rights and responsibilities. Follow procedure, use PPE, report hazards, participate in training. Penalties for non-compliance, fine, stop work, levels for accidents. Now, ADOSH-SF CoP number 27, 21, and 24. Now, confined space risk assessment exercise, PTW completion and review, gas monitor demonstration, emergency rescue drill, case studies that we have some. Now, module, confined space risk assessment exercise, like risk hazard, like see, identify hazard, assess risk, decide control, and hazard, then risk and then control. PTW completion and review. Fill permit, then verify isolation, authorization, sign off, check, authorize, and then sign. Gas monitor, then demonstration, then test, monitor, and act. Emergency rescue drill. We have to conduct the drill, see, for the like rescue and also the drill. C means the rescue, how to conduct the rescue. Now, case study discussion, incident, then rescue, then cause, then learn, and then end. Now, see, PGW also we will have three videos now. We will discuss written or verbal knowledge check, practical complete, essence, then assessment, course evaluation certificate. So, written, verbal. So, now we have to, if you have any question regarding this, please ask your question. So, I will revert to your question. Any question, please? Because we will go
Okay.
for videos. After this, we will go for videos and we will ask the question in the videos. Okay?
Yeah, yeah, sure. Sure.
Okay, so now we are going to the videos. I'll open the videos and we will go for the videos.
Okay.
Okay, let me stop this. The recording.